I'm very happy to chair the session for Dr. Vinay Kamble, VP Kamble. A wonderful good afternoon from India. I think it has been a lot of energetic presentations which has been happening over almost past 15, 16, 17 hours. And we have a lot more to see in this coming hours. I'm very fortunate to introduce Dr. VB Kamble, who is a mentor to me, as well as a very important person for activities, carrying out activities related to science communication and astronomy communication on India level. I think many people from our country would know him for what he has been contributing since over more than 40 years. Dr. VB Kamble has earned his PhD in theoretical nuclear physics in the year 1977 from Physical Research Laboratory in Ahmedabad. Since then, he has been constantly involved in dedicated work towards science communication and popularization. He was involved with the Department of Science and Technology, Government of India, since the year 1989, and has been a leading figure in this area of science communication and technology communication since almost 40 years. His contribution in the field of astronomy, communication, and popularization cannot be missed. He has been involved in mass communication and mass popularization events such as solar eclipses, other eclipses, transits, and several other themes related to astronomy and several other scientific subjects. His specialization has been involving different modes and methods of communicating to masses, may it be activities such as radio episodes, science train on for science communication, a lot of hands-on activity kits, or may it be also publications. There are enormous kinds of methods he has been involving. I have been fortunate enough to be constantly learning along with him during making a lot of hands-on activity kits on astronomy and different subjects related to science. So let us listen from him about how astronomy communication and popularization activities have been instrumental for bringing social change in our country. When we are talking about India, there are lots of misconceptions and there are lots of superstitions when we talk about astronomy. So such kind of activities have constantly been changing, bringing change. So sir, I hand over the session. I request you to mute your mic, and I request you to share your screen to the audience. So would you be requiring help? Over to you, sir.
Okay. Thank you very much, Kathan, and Dr. Carl Pennypacker, Dr. Rosa Durant, Dr. Gustavo Rojas, and my dear friend Kathan Kothari. It has really been a nice experience being here with all of you. And in fact, this is my first experience for this global webinar mode. And it's really nice talking to these participants from, let's say, all over the world, so almost 80 countries. So it's really a wonderful experience. Okay, so now what I wish to just, talk to you about is say about this popularizing astronomy for say, social change. I think it's rather an offbeat topic for all of us. And but then I mean, say in a country like India, and also I mean, so many I mean, say now developing countries, the situation is not really very different. And I must tell you that so now India is a very diverse country. And so now there are about 1.4 billion population, means almost I mean, so 1 out of 7 persons in the world is an Indian. And at the same time, so now I must also tell you that so there are about 22 major languages in the country, mind you, 22 major languages, and something like say well, more than say now 4 to 5,000 dialects there. In fact, it turns out that there are something like say 19,500 mother tongues which people speak, okay, in our country. And of course, obviously now it's geographically the country is diverse, and even obviously now in terms of obviously this linguistically and even culturally to a great extent, obviously this country is diverse. So it's really a study in say unity in diversity, and it's really a wonderful experience. Obviously now working obviously in this country, and this, but at the same time, I must also remind you that very often, so now in a country like this, so we have obviously now problems like, so now illiteracy, there's now there's a poverty, and obviously other obviously now related social problems. So now with these problems, these incumbent problems, so that we really have to obviously now find a way so that obviously we are able to, I will say now, progress. We can obviously now help people obviously now develop with a some scientific temper, think scientifically and act scientifically. So that has been a real challenge. Now, I must tell you that now I was, as my friend Kathan said, that I was with Department of Science and Technology, Government of India, and my job exclusively has been to obviously now popularize science and technology in the country. And mostly, say, I have worked in the field of say, astronomy popularization, and also I mean, now taking up several projects concerned with the students and teachers, and also I mean, so now coordinating with several organizations in the country, say especially research and development. I do not wish to tell you about obviously the research and developmental aspect of astronomy and astrophysics in the country. There are now many institutes, obviously many organizations which are dedicated, which are devoted to this research and development in the country. But at the same time, we uh, the, our special efforts for obviously now popularizing astronomy for social change, because now we can see that it is astronomy is something in which everyone is interested. Everybody has some sort of interest in astronomy. Say, irrespective of the race, irrespective of the social level, so now the person is really interested in the change. I really wish to tell with this background, I wish to take you, say, the something like the 3,500 years, almost 3.5 millennia say, back. And I will say now tell you how the country has obviously now developed. Now, how obviously the science has developed. Now, let me tell you that India has one of the oldest histories, starting with the Indus Valley civilization, Harappan civilization, which is something like the 2500 BCE. So that is almost obviously 4,500 years ago. Now, Indian astronomy, it has a very long history, so stretching from prehistoric to modern times. So it's really very long indeed. And so now the Indian astronomy has its roots. during the periods of Indus Valley civilization, as I just said. And that was also the time then, I mean, so when people, I mean, so started, I mean, so thinking about, I mean, the social development, also, I mean, so now started, I mean, so looking around, started taking observations of nature, and also, and which also say involved the observations of the stars and planets and say other, I mean, say, celestial objects. So that is how the Vedic astronomy, as it is called, say it's really started with the advent of the Vedas. Now I'll tell you about now Vedas, what the Vedas really mean. So that was something like almost 1500 BCE, or almost I would say 3500 years ago. Now, essentially, Vedas. So these are the oldest scriptures of Indo-Aryan period. Let me remind you, they are the oldest scriptures. And Vedas, essentially, it means knowledge. Veda, that's in Sanskrit. It's a Sanskrit word, and it really means, I mean, say this knowledge. And it's a body of knowledge in the Indo-Aryan period. So there are basically four Vedas, and I'll very briefly tell you what all they contain. So okay, our story really begins there, and I want to bring you a visit today. So the first Veda which developed was a Rig Veda. And, now Rig Veda contains a hymns, say, which are about mythology and also about say, some of the origins of this religion and some stories. Okay, now related to obviously some of the mythological characters and stories. And the other one, Yajurveda, which is really considered to be the main Veda, that contains instructions for religious rituals. So that is the time when the religion really, I mean, began in India. And so now this the third Veda, is the so-called Sama Veda, that consists mainly of hymns about melodies and chants. So that is one thing that's really basically these are the songs, and many of these about these hymns, they are taken from the Rig Veda and also Yajurveda. And last Veda, that is the fourth Veda, that is called the Atharva Veda, and that consists of formulae for daily rituals for initiation into the learning of the basics of life. So fourth Veda is it tells you the basics of life. So this it also contains royal rituals and the duties of the court priests, and also they are included in the Atharva Veda. So these are, I will say, the four Vedas, and that is really the repository or the oldest scriptures, say which our I will say this oldest, I will say, repository of knowledge has. These are the four Vedas: Rig Veda, Yajur Veda, Sama Veda, and Atharva Veda. And these are the oldest scriptures I would like to re-emphasize. Now, this Vedic period, it really means it's about, say, from considered from 1500 to 1200 BCE to almost 500 BCE. So now that's almost a 1500 to 2000 years. I mean, so now this Vedic period has continued in the country. And throughout these Vedas, we find, I mean, references to celestial events. That's the basically that was the time people have taken, I mean, very keen observations of the this thing, say the celestial objects, celestial events, and also the accurate naked eye astronomical observations. It's really amazing the type of, I mean, say the accuracy with which they have been able to take the naked eye astronomical observations for that period. Now, this is which is really forms what we call today as Vedic astronomy. Now Vedic, now there is no separate section like say astronomy, but then we find, I mean, now references, I mean, to different, I mean, there's observations, different celestial events scattered through different, say Vedas at different places. Okay, so that is how say, most of our knowledge comes in, say, from Vedas, and the way that is all collected. So what develops is once an ancillary discipline, and which is called Vedanga. So now this ancient astronomy developed as a discipline of Vedanga, or one of the auxiliary disciplines which is associated with the Vedas, which is dating back to almost 1500 BCE. So our Vedic astronomy really is, I would say now, almost that old, almost, I would say now, 3,500 years old. The oldest known text is Vedanta Jyotisha, old Vedanta Jyotisha, which was said to have been written sometime in 400 to 1200 BCE. So I would say now this Jyotish, incidentally, it means light, and that actually, I mean, say what it implies is the study of astronomy, astrology, and the science of timekeeping using the movement of astronomical bodies. So it has been really a record of, I would say, the astronomy of during those days, which is almost, say, almost 3,000 to 3,500 years ago. Now, this it's not that say Indian astronomy has developed in seclusion. Say, Indian astronomy has developed, say, through I will say now interaction with other I will say now cultures and with other distinctions, I will say the branches of knowledge as well. So now Indian astronomy was influenced by the Greek astronomy mainly, and that began sometime in the 4th century BCE. That is that coincides with the conquest of Alexander the Great, and that was the time when Alexander the Great, I would say now, invaded India. That was the time, said out our fourth century BCE, and the lot of interaction between the Greek astronomers and the Indian astronomers also took place. In fact, there were several books which were translated from Greek into Sanskrit. That's really interesting. And also this interaction continued through the early centuries of the Common Era. And now this Sanskrit translations of this Greek text disseminated from the 2nd century in the Indian context. So basically, this Indian astronomy blossomed in the 5th and the 6th century, really speaking. So Indian astronomy was really at its peak during the 5th and 6th century with great astronomers and mathematicians like Aryabhatta. Aryabhatta, I will say, is a very well-known name, and his this important, so-called this most important, I will say, now book written by him is called Aryabhatiya, and it is that represented really the pinnacle of the astronomical knowledge at that time. We shall presently see what was his contribution. But then here is the one picture, this picture of a statue of Aryabhatta. Now this is housed in the Indian Inter-University Center for Astronomy and Astrophysics at Pune, which you see on the left-hand side. So that is, I will say, this Aryabhatta, and then on the right-hand side you see that Aryabhatiya, and that the important work of Aryabhatta. So now this growth of astronomy. Now, if you now really say this, Indian astronomy, in fact, also influenced Islamic astronomy and the Chinese astronomy as well. Now, quite often say now it has so happened that the Arab traders and these Indian traders, they had a lot of trade through the sea route. And so, I mean, now there was a lot of exchange of knowledge of this astronomy, especially for the navigational purposes between, I mean, the Indian traders and the Arab traders. Okay. So now this is how it happened. And then that is how the astronomical knowledge which India had that got transmitted to Arab countries. And from there, so now through Arab traders, it reached the European countries. And that is how this European astronomy was influenced by Indian astronomy through Arab traders. I think this is important to note. So other astronomers of the classical era, so who further elaborated on Aryabhata's work, included Brahmagupta. He is a very big name. In fact, when we talk about this zero is a gift of India to the world. And I mean, it is Brahmagupta was the person, who was the mathematician and astronomer who invented zero as a number and introduced into the theory of numbers and also the mathematics. So now the other arrays are now the sages like Varaha and Lalla, they were responsible for development of algebra and trigonometry and number theory and so on. We shall not go into the details, but then I will say here is a picture of this Brahmagupta, the inventor of zero, which that was sometime in the 6th century and 7th century. And also this Varaha Vihira, now as a result of obviously these various developments, and also obviously because of this combination and interaction with this Greek astronomers, this later astronomers mentioned the existence of various siddhanta. Siddhanta means theory during this period. Among them, there is a text known as Surya Siddhanta. So these were not fixed texts, but then say they were passed on, say, through oral tradition from one generation to another generation. So their content is also not really, I would say now, extant. But then the text today, which is known as Surya Siddhanta, incidentally, Surya means, say, sun, is in Sanskrit, and Siddhanta means theory. So it dates back to the Gupta period, that's almost 6th century AD. And the classical era of Indian astronomy begins in the late Gupta era, that is almost 6th or 7th century. In the 5th to 6th centuries, that is really. And there are also with the Varaha Vihira, as I referred to earlier, he wrote obviously one important obviously treatise called Pancha Siddhantika, meaning obviously it is 5 theories. In fact, two of them were obviously now from with the help of obviously now interaction from these Greek astronomers. So it approximates the method of this meridian direction from any 3 positions of the shadow, say of using a known. Now, now this after I will say this in the medieval periods, if we come, by the time of Aryabhata, the motion of planets was treated to be elliptical. This is important, and this was really the contribution of Aryabhata. The planets were treated to have these elliptical orbits rather than circular, and other topics included definitions of different units of time, eccentric models of planetary motion, and epicyclic models of the planetary motion, and planetary longitudinal corrections for various terrestrial locations. Okay, so these are some important aspects. In fact, Aryabhata also pointed, but not explicitly said, about the say now heliocentric theory. But then I mean say now his I will say now theories did point to this heliocentric theory. But he did say that the Earth rotates on its own axis, and that is why we see the universe moving. That's why we see the stars moving, the rising and setting, etc. So, so now there are, but there in the 16th and 17th century, a school of mathematics flourished in South India. That was Kerala basically, and that was basically astronomy and mathematics. And another thing that was in the south and in the north, the experimental aspect of astronomy. Say Jai Singh, the king Jai Singh, so he was the one. Now the picture which you see here is Nilkanta Somayaji, is again a well-known name, say, who wrote treatises on this mathematics and his original researches in this astronomy. Now Jai Singh, this is Jai Singh who lived in the period 1688 to 1743, and then say he built observatories. These are, I mean, say now observatories. These are there. It has something like say 29 instruments, and now he built 5 observatories now in Delhi, Jaipur, and then say now and also in Banaras and 2 other places. I mean, so he built the observatories. From here, I mean, so you can, I mean, so find the altitude of the stars. From here, I mean, say this is really a number, and then say you can find, I mean, say the from any latitude from for the any city. I mean, so you can find the approximate time. And from here you can find the different aspects of the stars. Okay. So these are, I mean, if you visit Delhi or if you visit Jaipur, I mean, don't forget to use a visit, I mean, this observatory for Jai Singh. And then now, when we come to astronomy and religion, now it is of course true that whenever we talk about this astronomy, the religion normally, I mean, is connected with astronomy because so many astronomical objects, especially the sun and the moon and then the other planets, they are considered as deities. So now some of this astronomy, this thing, so now can be dated to the period again of the Indus Valley civilization, but we won't go that far. So some cosmological concepts are also present in the Vedas, as are the notions of the movements of heavenly bodies and the course of the year, and so on and so forth. As in the other traditions, there is a close association of astronomy and religion during the early history of science. So now these astronomical observations, they became really necessary because I may say because of the religious rituals. They have to do the religious rituals at some certain time and some certain space. So the spatial and the temporal requirements of the correct performance of this religious ritual was something very important, and that is how even the the construction of the sacrificial fire on the altars, sacrificial altars. So now they were also very complicated. They were very involved, and these are called Shulka Sutras, which discuss advanced mathematics and basic astronomy. And in fact, you will also find Pythagoras theorem there. Okay. Now, timekeeping, say in India, say we shall very briefly discuss this timekeeping in India. Say now how it all started. So that is to bring the say our I mean, say now basic this it brings some sort of an order in this society, and that's why. So now when some order has to be established, and that's why the timekeeping is necessary. So that was, and also timekeeping was very important in the Vedic rituals. That is, and then the Jyotisha was employed in tracking and predicting the movements of astronomical bodies like the planets, the sun and moon and other stars, and in order to keep time. So now, so that could help decide the day and time of these rituals. As mentioned in the one important, let's say now, let's say book called Shatapat Brahmana. Okay, that was almost 700 BCE. Now, this study was one of the ancient Vedas and that's ancillary science, and it really again came from Rigveda and the Yajurveda. Now, movement of these celestial bodies and timekeeping. Okay, now that was again, I mean, mentioned by Brahma Siddhanta. The main work by Brahmagupta, probably composed in the 5th century, this Christian era, that discusses how to use the movement of planets, the sun and moon to keep time and the calendar. That is where I will say the I will say now idea of this calendar began. And this text also lists trigonometry, mathematical formulae to support this theory of orbits and predict planetary positions and calculate relative mean positions, celestial nodes, and so on. It's really notable for the number theory, and it can be very large integers. Okay, and then it also presents mathematical formulae to predict the length of day, time, sunrise, moon cycles, etc. Now, modern Hindu calendar, when we talk about, that is where, so this, that was really, say, the important aspect, I will say, for bringing into society some sort of order. So now this modern Hindu calendar, so sometimes is referred to as Panchanga. Panchanga, it has really 5 basic aspects, so it's called Panchanga. But then it's a collective term for various lunisolar calendars. Indian calendars are lunisolar calendars. So in the sense that I will say they follow the motion of the moon for keeping track of the days and for keeping track of the festivals and I will say now all the worship etc. And but at the same time, say it keeps I mean a pace with the solar movement, solar motions. Okay, and how do they do it? They adopt a very simple now very simple concept. In fact, they adopt for timekeeping. Uh, but their main emphasis is on moon cycle. Okay, either from new moon day to let's say new moon day or from some full moon day to full moon day. And the names of months and when they consider the new year to start, everything depends on the moon. But then the ancient Hindu calendar is similar to the really old Jewish calendars, but different from Gregorian calendar. Because in Gregorian calendar, say we have 365 solar days. In Hindu calendar, say now that it maintains the integrity of the lunar month only. So then it has 354 days. But it inserts one extra full month and that is called Adhik Mas. Adhik means extra Mas this month. So it inserts what's a extra month, full month by complex rules, generally after 3 years or so. So now to ensure that this lunar calendar keeps pace with the solar calendar. So now that's how we keep pace with the seasons. That's how we keep all the different festivals. Say don't really fall off the seasons, they fall in the correct seasons, and then so now that ensures the festival and even the crop related rituals also fall in the appropriate season. So that's really a very now a clever way of maintaining lunar as well as as the solar now the pace. So that's one thing. Then I will say now, but now there was one thing say I must tell you that say now with this there was during, I mean, say uh, after, I mean, say this period, so sometime in the year, I mean, say 1100 AD to almost, I mean, say now 1900 AD. Okay. We had obviously now problem because of this several obviously invasions from the sort of foreign rulers, and then obviously there was a lot of political instability, and also because of the British rule in the country, East India Company for about 200, 250 years. So they were, I would say, that is during the pre-colonial era. People, I will say now, that again, I will say now, the science and the progress of science, astronomy, it really suffered. But that was also the time people, I will say, became, I will say, somewhat satisfied with the simple agro-based, I will say, now lifestyle, and did not really feel the need also for innovation and innovation, which is really, I would say, somewhat sad. But so now, so all knowledge related to science, therefore, it's also somewhat more secretive. And so that is why so there was some, you could see some decline in the scientific activities during that period. So now, really speaking, so now it's rather obviously a sad thing, but it's almost obviously for 1,000 years. Say now there was we really had, it was really a sort of a dark period. But in some places, in some parts of the country, the astronomy still flourished, especially in the south and in the north, say, for example. So it was only during the last 5 decades, mind you, last 5 to 6 decades or so, that concerted efforts spearheaded by government and the non-government organizations and agencies really began taking place, I would say, and for taking science and technology to the people. So in particular, say astronomical phenomena like say eclipses, they are always viewed in general by the people with wonder and awe, and also means coupled with fear. So like they as if they bring some sort of say evil say, on the mankind. Okay, so which makes the people take refuge in religious practices or superstitions and blind faith. So this is really something that I say we need to obviously keep in mind. That say now, say that this is something say where we need to educate the people, the school children especially, and the general public about this astronomical and other natural phenomena. I mean that would not only help them develop a rational outlook, but also help them think and scientifically and act scientifically, ushering in the social change. And this is where the astronomy has really, I mean, say now helped. I have been watching the evolution of, I mean, say now this how, I mean, say science and technology communication has developed in the country, and especially in the science of this astronomy popularization. So this was, now you are seeing these pictures, so many children watching, I mean, the solar eclipse, I mean, says of 2017, so much of interest. This is only a recent phenomenon. So now, if you saw something like say 30, 40 years ago, things were say, very different. Because now what happens is, so now the reason most scientists don't believe in astrology, we know that it is not consistent with our theories which have been tested by experiment. This implies that for a subject to be projected as science, it must be refutable. It must be it necessary to examine whether it follows the scientific discipline. Okay, that is by making specific assumptions on which it rests. So it has follows that the predictions need to be accompanied by tests to prove them right. Okay. So indeed, this is how science and society have progressed. And sometimes the basic idea of assumption on which the theory is based may need to be modified or even discarded depending on the observations. Okay. So now this is now Now, in the case of Vedic astrology, which is followed in India, so we do have say the planets, and we do have and what are the planets we use in India's say Indian astrology? Sun is a planet, Moon is a planet, Mercury, Venus, Mars, Jupiter, Saturn, they are planet anyway. And in addition, so there are two obviously now so now unreal, or that is the now planets which are called Rahu and Ketu, and Rahu and Ketu do not even have any physical existence. Okay. And what is more, when Uranus, Neptune, and Pluto were discovered, they didn't even find any mention in the Hindu astrology. So these are, I mean, say, things at variance. So this is what it is, I will say now. This is the ascending node of this moon, and this is called this Rahu. This node is called Rahu, and descending node of the moon with the ecliptic. This is called Ketu. These 2 points, ascending and descending node, these are called Rahu and Ketu, and these are treated as two say, planets in the Hindu astronomy. So, but in any case, astrology has played an important role in the growth of development of human understanding of natural phenomena. The study of planetary motions was prompted by demands of astrology, which is very true, for determining planetary positions with greater accuracy. Just the way alchemy led to the study of chemistry, astrology has led to the study of astronomy. So astrology had its influence on human history as well, as study of which this could certainly be relevant and useful. So this is now with this in mind, so that in government, especially since 1980, this special program, special wing started in the government of India called National Council for Science and Technology Communication. And another, I mean, say, organization called Vigyan Prasar, means, I mean, say, the spread of science. Another organization started with this very purpose to, I mean, say, now spread science and technology in the country, to disseminate science and technology in the country, and help people, I mean, think rationally, and act, think scientifically, and act scientifically. So, now we see that whenever there is an eclipse, there is a whether partial eclipse or say total eclipse, solar or lunar, or I mean say even now transits of Mercury or Venus. So now there is a spectacular event like this. So many children and many they are accompanied by their parents. They throng planetarium, schools, and even I mean say now wherever the special arrangements are made for safe observation of the eclipse. You see. In fact, what is really important, what is really interesting to note is that the sparkle in their eyes when they have a look at, I will say, this eclipse sun, or maybe I will say this when they see, I will say the I will say the transit. You can see, I will say this. These are the eclipse watchers. These are in hordes. These are in hordes. You see. Now these are either, let's say, there are now say we have several science cities in the country at many places. And for this purpose, say now with the help of obviously Manthan organization and several other organizations, we have been making, I mean, some very educational modules, I will say, very, I will say, now activity kits, which also has this, I will say, those these safe solar viewers. And with this, I will say now it is really now spreading this the science communication or science popularization, and then the astronomy popularization especially is spreading like say wildfire. Okay. Now one thing is that for science in Indian media, it still has to obviously now go a long way. Now you can see that in India, whenever you have this any say say live commentary say about on media about any celestial phenomenon like say eclipse or maybe a transit or so. Normally you will find there is a scientist sitting, and also they are invariably they also call one astrologer. So this is really something wrong. And always, even today, so it's really sad that many of the astrologers, they say that now pregnant women should not have a look at the eclipse, because if they do so, then now they will give birth to physically deformed or mentally retarded children. So now these are the kind of it's a blind faith. These are the kind of superstitions now say we have been trying to overcome through various means, and so that's what now we have been trying to do through our this different media. So now this is the Venus transit. You can see here that a small child, his mother, is not really very much educated. She has been trying to, show this Venus transit. This was an actual picture taken here, say in Ahmedabad. Okay, so now, this is something we really need to take care. That now we need to now educate the communication channels and the television channels, so which really can develop the right type of opinion, help people think scientifically, and also transform this nation of this 1.4 billion into a scientifically thinking people. But there has been a perceptible change, you see. I have really dwelt on the concerted efforts of government and non-government agencies in popularization of astronomy in the country. Say on an earlier event of total solar eclipse, which was in 1980 on 16th of February. Okay, so that was something like say 40 years ago. There was a virtual curfew in the country. The eclipse was in the afternoon. I was on an expedition of this total solar eclipse in Karnataka in South India. And this after the eclipse, there was no restaurant open where we could eat something. Okay, so because now people have to observe fast after the eclipse. So there was a virtual curfew in the country, since eclipses are considered to be harbingers of evil omen. But as a result of our concerted efforts on a similar occasion on 24th October 1995, that is how much say, after say, almost say 15 years or so, people everywhere in the country thronged outside their houses, on the streets, on the grounds, in the parade area, in the schools, to have a glimpse of the totality during the safe, using the safe solar filter here, and say so school children and people now look forward. In fact, they look forward. They want to know. See, curiosity is always present, and the children and the people in general, they say they are very curious to know. They want to know something. So they are very observant, and they want to understand the astronomical phenomena, and that is where our efforts are now directed to. So I would say this is what it is. So and it is now triggering an interest in science. Astronomy is one thing which is really triggering an interest in science among students, teachers, and general public. And but there are now several other now efforts which we need to put in. I just would like to mention in passing an effort called this Vigyan Rail. Vigyan is science and rail means train. So it's a science train, a science exhibition on wheels. So that was undertaken in 2003. And here is a train, fully mounted train of some 18 coaches. And this is really, this is a coach on environment. This is a coach on say now forest and etc. And you see, the number of people say, who are thronging into this science on these gathering. So this is another effort. So this type of efforts have to go on. Astronomy is extremely important because everybody is interested in that. And because people now what we have learned is that everybody has some innate curiosity, innate now thirst for knowledge, and we must cater to that thirst. We must cater to that this I mean, so now that change. So this is something, which is now slowly bringing about a social change, which I have witnessed in last, I mean, say now 25, 30 years, and I have been witnessing it. So now there is no gainsaying the fact that astronomy has not only expanded the horizons and perceptions of the universe, but also has contributed to our intellectual growth, fired the imagination of the young, and help bring about a social change. So that is what I would really wanted to, I mean, say now tell you, and I hope that you have, I mean, say, enjoyed the journey of the, which started from 3,500 years ago till today. I mean, say where, I mean, say now our country stands, and with that, I would like to thank you for, I mean, say, listening to me. Thank you.
Thank you, Dr. Kamble, for taking us through a journey of almost 3,500 years. It was a very interesting journey where you started talking about different things related to religion, related to different efforts being taken in the entire country. There are three questions which I see by the same person, Azim Khan. I think the first one, I think Azim has been already answered when Dr. Kamble, so he's trying to say that why do we bring religion into science communication activities? But I think when you went through the presentation, you have already shared a lot of information related to that. The second question by him is the Indian and had lunar based calendar, but now we all fellows follow Helios based calendar. Why did it happen in that manner? What is the reason of the transition? So this is his question. And I am joining the second question also, which he's asking, which I think it's a very simple answer. Is there some change on the Earth during lunar or solar eclipses? So these are two questions by him.
Okay. I mean, the first question, I believe that now, why are we still following the lunisolar calendar? Is that so?
Why are we following the Helios-based calendar, and why the Indian lunar-based calendar has no existence now?
Now, I will tell you that say in India now there are, I mean, say now say hundreds of calendars which are being used, and say most of the calendars which earlier started where, I mean, say based on the lunar motion, because one thing is that the lunar motions, I mean, say now much easier to track. Every day you see the moon, and then, I mean, say every day the moon's shape is also different, so it is easier to remember, and say again from say new moon to new moon, or say full moon to full moon. So that is how really the lunar calendar started. But at the same time, people realized that say this is not keeping pace with the seasons, especially agriculture or and say other seasons. I mean, say it has to keep pace with the season. So they realized that say now this sun, I mean, say now is an important entity, and say it is this, and we have to, I mean, say, keep pace with the sun, and that is where the, I mean, say this solar aspect also entered, and then, I mean, say now this solar to keep pace with the solar motion, they had an artifice. So that artifice was that say every 3 years they would add, I mean, say one additional month called the Adhik Mas. So they still want to follow the festivals according to lunar calendar. That's the idea. Most of the festivals they want to follow with the lunar calendar, but they don't want to lose, I mean, say the that particular festival falling say in the out of the season. Say like some particular, I mean, say festival. Say if it is falling in say winter, it should not fall in summer. It must fall in winter only. So that means it must keep pace with the season. So it must follow, I mean, the tropical calendar, which is the solar calendar. Then that is how, obviously, now this artifice was made, and then the lunisolar calendar, that is how it came into existence.
Okay. So the second question was, is there some change on the Earth during the solar eclipse or lunar eclipses? And then we have 5 minutes remaining, so there'll be one more question which we'll be taking, which is in the question box. Please go ahead, sir.
No, sorry. No, can you
Is
repeat
there
the
any
question?
is there any change on the Earth during lunar or solar eclipses?
No, no, no. There is no change. Say, except that say now, so the lunar, solar eclipse. The only thing that happens is that I mean, say now some of the light from the sun is I mean, say now cut off because of the moon shadow, and then so now there is only the less radiation, the solar radiation coming. So there is no change I mean, say, on this. But then say at the time of total solar eclipse, now suddenly what happens is that because I mean, say now the intensity of the light goes down suddenly, and then I will say now it's as if the night has fallen. So quite often I will say now many birds I say they get confused. We say they don't know suddenly. How is it that it has become evening? They start returning to their nest. Many of the animals they get confused. So now this sort of obviously things you do observe say, during the total solar eclipse, but otherwise obviously partial solar eclipse you don't find anything. Similarly, in the lunar eclipse, you don't find say any such thing. There is no change happening on the earth as such.
Sorry, I was on mute. There's one question and comment by Niru Mohan. So she's saying that Niruj Mohan, in addition to the historic astronomy practices that are linked with religion, it would be also useful to highlight various secular and astronomy traditions in India that have evolved independently of the priestly class, fisher people, and the farmers. There are many different practices. So if you want to share something about that, sir.
A different what I will say. I have difficulty in hearing, so you can tell me again.
Sir, there are different practices which are specific to astronomy traditions. Like there are different practices amongst fisher communities, farmers, which are very specific to our country. So if you want to share something about that, sir.
Oh, I see. Okay. Now, you see, I mean, say this. Yes, it is true because I mean, say normally you know that say on the full moon day, the new moon day, there are say high tides in the sea. So obviously their catch is also obviously now affected, especially the fishermen. And so obviously now they really obviously have to keep track of obviously the lunar motions and so obviously that is how this the full moon day or new moon day, these are really important for the fishermen community. And there are some other communities also that depend, I would say, on this kind of living. So they do have to keep track of uh, this things, lunar and solar motions.
So I'm taking up the last question. So there's a comment by Liois. Um, uh, the person is mentioning very interesting talk. Thank you. They want to know about, are there any educational resources that you can recommend based on ancient Indian astronomy? Something similar to Eratosthenes method for measuring the size of the Earth.
Say,
Are there any specific educational resources that you can recommend based on ancient Indian astronomy, sir?
yes, yes. I mean, yes, yes. I mean, say there have been, I mean, say now, the mention about, I mean, say the size of the Earth and the radius of the Earth. In fact, I will say now some of the our older astronomers like say Aryabhatta or even say this Brahmagupta, it seems I mean they did measure the distances and also the planetary distances and also I may say the diameter of the Earth. So now those are documented and those can be available. Right now, I do not have it at hand, but that can certainly be found out and given.
Um, just a comment by Ashwini Shenoy. Uh, he wants to say that speaking as an Indian, he wished to know if you could share any experiences of challenges of bringing science and astronomy to non-English speaker particularly in rural and semi-rural areas? Like, what are the kind of challenges you have faced? And that's the last question. We have 1 minute on us, sir.
Okay. Now, see, one thing is that now the superstitions and then the blind faith are quite often very deep rooted, especially in the rural areas, and also obviously wherever the literacy is low. And when this happens, obviously it really becomes difficult to deal with them. You cannot you can only address the blind faith. You can only address obviously the superstitions. But you cannot if you say that I want to remove the superstitions, then that's a wrong approach. You cannot do that. You can only slowly, I mean, say, take the people in confidence, slowly, I mean, say, show them, I mean, say, some experiments, I mean, say, well, it's very simple experiments to start with, and then talk in their language, and then, I mean, say, slowly, I mean, say, only you will be able to get over, I mean, say, these superstitions. So now, these problems we have faced, and we still face, say, in the rural areas, and also in the areas where people are illiterate. Yes, these are problems, and these are genuine problems, and they do require, I mean, a lot of effort. And there is something, sometimes some methods, especially, I mean, now developed for, I mean, that particular group. Yes, I agree.
Thank you, sir. Thank you for taking us through this journey. It was a wonderful session. I hope everyone enjoyed it. I hope there was a lot of learning and which you got through the session. I would like to hand over this session to Fraser, who would be introducing the next speaker. Over to you, Fraser.